Hey physics students, it's time for Newton's second law. You might have been wondering now for a while. We know what Newton's first law is. Just a little recap for you. Newton's first law is the one that says something like things keep doing what they're doing. In terms of their velocity, that is, unless acted on by not any force, not an outside force. That's not really the right way to say that, although that's how it's often stated. Don't like that. Unless acted on by an unbalanced force. That's the key. So that means that things that are at rest keep being at rest. Things that are moving at a constant velocity keep moving at a constant velocity, unless that unbalanced force shows up. How about Newton's third law? So that's the one that says something like force is an interaction between two objects So force on one of them is equal, but in the opposite direction. That's not a C, that's an open parentheses. Opposite direction as force on one, or the other one, rather. So those two objects are interacting, then the force that they experience is exactly the same in magnitude. It has to be the same because there's only one force there. There's only one interaction, but opposite direction. Okay, so what about Newton's second law? This is the one that comes with an equation, and here it is. You want to know how much acceleration you're going to get? If there is an unbalanced force, then that's going to change the velocity of something, and if you change the velocity of something, that's acceleration. So here is how we quantify that. The amount of unbalanced force that there is equal to mass times acceleration. And maybe you've heard this before, force equals mass times acceleration. But it's not just force equals mass times acceleration, it's unbalanced force equals mass times acceleration. There's your notes, that's it. Well, maybe we should talk about a couple examples and make sure that we understand how to deal with this. So force diagrams are really, really important. So let's say we have an object with a mass equal to, let's say 2 kilograms. And let's just make that the mass for of this object, and let's put that object in a few different situations here. How about if there are, so this would be 2 times 10, that'd be 20 newtons of gravitational force, right? If the mass was 2. And then there would be a normal force there. And let's say there's somebody pushing on it with a force of 10 newtons. How much unbalanced force is there? Well, the forces are balanced in the up-down direction, so those cancel each other out, right? That does not contribute to the unbalanced force. How much unbalanced force is there? This right here is how much unbalanced force there is. So what we would do here is we would say the unbalanced force here is equal to, sometimes there's like a tug of war, like the winning side versus the losing side, but here it's just the force of that push, and there's nothing the other way, so minus nothing. And if you want to then do some math, well, unbalanced force is equal to mass times acceleration, and the force of this push is 10. So if I plug in the mass 2 right there, so kind of running out of room here, you can keep going down on your page. 2a equals 10, so a is 5 meters per second squared. Right? Now let's say that instead of that, how about let's say we have this, and let's say we have the same force of gravity, support force, and the force of push here. But let's say there's some friction here. So force of friction here is 5 newtons. Those still cancel each other out. But now the unbalanced force here is equal to, I like to call this winners minus losers. I'm going to say that a million times till you're sick of me saying it. So force of push, that's winning, so the winning side, minus force of friction. So now my unbalanced force, mass times acceleration, is equal to 10 minus 5. So the acceleration is 2.5 meters per second squared. And that's basically the game that we're playing. And I think that, well, maybe I'm just going to give you one more example. Let's say that our object of 2 kilograms was resting on the floor of an elevator. Physics teachers love elevators. And that elevator is accelerating upward with an acceleration of, let's say, 2 meters per second squared. And here's my little mass here. This is going to get you ready for doing the first problem in your homework. So, well, what's going on here? First of all, we have to recognize that the forces on this, it's in an elevator, sure, it's just resting on the ground, but these forces, the force of gravity and the support force, are not balanced. It's not possible for this thing to be accelerating up unless the forces are unbalanced. Not only that, they have to be unbalanced in the direction of the acceleration. Not the direction of motion, but the direction of the acceleration. So what does that mean? It means that here's the force of gravity. You know what? Does gravity change? No. Gravity doesn't care about you or me or this 2 kilogram mass. Gravity's always going to be 20 newtons on this thing. Doesn't matter what's going on. And there must be, I'm going to exaggerate it here, a support force that's bigger than this, because if this thing is accelerating in the up direction, then there must be unbalanced force in the up direction. The direction of those two things always must be the same. Okay, so could I figure out how much unbalanced force there is? Yes. We're going to approach it in the same way. The unbalanced force, sorry, I did this little sigma thing here, sorry. In, I don't know if you've ever seen that symbol in math. It means the sum of, and we do that in AP Physics, so sometimes I accidentally switch up the notation. We're just going to write unbalanced, force unbalanced, like that, and not use that symbol. Sorry about that. So force unbalanced here, the support force, or the normal force, must be winning, because it's accelerating up. That's how I know. So let's see, unbalanced force is equal to mass times acceleration. The support force, I don't know what that is, that's what we're trying to find, minus the force of gravity is 20. And now I know the mass of this thing, it's 2, and I know the acceleration. Oops, dang it. Kind of did the math and then didn't do the math at the same time. 2 times 2 right? That's the mass times the acceleration is equal to the normal force minus 20. So the normal force is 24 newtons. So we figured out if this thing's accelerating at 2 meters per second squared, then there must be 4 extra newtons in the up direction. Have a lot of students make the mistake where they do unbalanced force is equal to mass times acceleration. They're like, oh, that's 4, and they just make this 4. But it's not. This isn't 4. This has got to be 4 bigger than that, right? That's why we write these equations here. All right, there's nothing else to do here besides just try some problems, try to get your feet wet. Make sure you use the video as well. Go back and forth with you do some, I do some, and we do it together. Okay?